In this video of the series Essential Differentials, we'll be covering the product rule, which is really useful because you always have some kind of thing multiplying with another thing. So this is how the IBAA formula booklet has the product rule written. I don't think it's very intuitive where this all comes from, and that you might forget what this means in a pinch when you really need it. So let's say you have a function which is the multiplication of two functions, f of x and g of x. Your differentiated function will always be the derivative of the first function times just the second function plus the first function times the derivative of the second function. So it's kind of neat. You can see how they alternate, and that this is used once, this is used once, this is used once, and this is used once. All the function and their derivatives are used once. And you just have to remember that in this order. And if you remember in this order, it also helps later when you want to use the quotient rule. So let's try an example. Let's say you have x squared, y equals x squared times 2x minus 1. So you could just expand this through and probably have an easier time just using the power rule, but for the sake of using this as an example, I'm going to use the product rule. So first we have, if you remember, this times this plus this times this. So the function here and the function here. The function of the derivative of x squared is just 2x. Two x multiplied by the entirety of the g function added by the f function multiplied by the derivative of the g function. Derivative of 2x is just 2. So you would get 4x squared minus 2x plus 2x squared. This simplifies out to 6x squared minus 2x. Okay. So when we want to use the product rule in conjunction with the chain rule, then we'll have to decide whether to use the chain or the product rule first. For this example, 4x times 2x plus 1 all cubed. We have the multiplication of two functions, sure, but we also have an outside function and an inside function. So I suggest we use the chain rule first here, because trying to multiply this out when this is cubed will take a lot longer. So let's call this part u. So we'll have y is equivalent to 4x times u cubed. Now the reason why we're able to write y in terms of two different variables is because we know that u is just in terms of x. The u is just for our own simplicity. So let's use the product rule on this part here. dy dx will be equal to the derivative of 4x, which will be 4 times the entirety of the second function, u cubed, plus the derivative of u cubed, but remember we have to multiply by the chain as well. So we'll get 3u squared multiplied by the derivative of the inside function, which is just 2. And don't forget to multiply by the first function again. So if we expand these out, we'll get that 4u cubed plus 3 times 2 times 4x, we'll get 24x u squared. Now, a common term in both of these is 4u squared. So let's factor that out. 4u squared, and I'm going to make this clear with a big orange bracket. 4u squared, what's left here? U plus 6x. Okay, now that we have all our terms, let's plug our u back in, which was 2x plus 1. We'll get that 2x plus 1 squared times 2x plus 1 plus 6x is our derivative of our first function here. So you can see how using the chain rule within the product rule, we managed to save some time through the multiplication of a few more things. But never ever forget to multiply by your first function again. Okay, and that's all for the products video.